Imagine you're sitting in a clinic.
Yeah.
You've been having some chest pains, so you were sent to get an X-ray.
Right.
And the doctor walks in, and you hand them a completely blank piece of paper.
Just totally blank.
Yeah, totally blank. And you're fully expecting them to stop, look at the page, and ask, like, hey, where is the actual scan?
Of course.
But instead, the doctor stares intently at this empty white page, nods gravely, and confidently diagnoses you with a severe, life-threatening heart condition.
Wow.
I mean, it sounds like a bizarre, anxiety-inducing dream, doesn't it?
It sounds like a scenario that ends with the clinic, losing its medical license and facing a massive malpractice suit, honestly.
Yeah, you would sprint out of that office.
Yeah.
But today's deep dive explores a groundbreaking research paper from Stanford University. It's titled Mirage, The Illusion of Visual Understanding.
It's a fascinating paper.
It really is. And this research reveals that our most advanced, state-of-the-art generative AI models, I mean, the exact same models that are increasingly being integrated into our healthcare systems, our businesses, our daily apps, are doing exactly that.
Staring at blank pages.
Exactly. They're staring at blank pages and diagnosing heart attacks.
It is a phenomenal and, frankly, a terrifying piece of research.
Okay.
We are talking about the absolute top-tier, frontier, multimodal models here.
Right, the big ones.
Yeah, the heavyweights designed to process both text and complex images seamlessly, or so we thought.
So our mission today is to uncover why these highly sophisticated AI models are essentially seeing things that just aren't there.
Yeah.
We're going to break down how they are absolutely acing complex visual tests without actually using any visual information at all.
Which is wild to think about.
It's completely wild. And most importantly, we want to look at what this means for you, the listener, the next time you rely on an AI to analyze an image for your work, your studies, or your health. Okay, let's unpack this.
Let's do it.
When we use a vision language AI, the basic human assumption is that, well, if we upload a photo and ask a question about it, the AI actually looks at the photo to find the answer.
Right. It's the most natural assumption in the world because we project our own human cognitive processes onto the machine.
Right.
Like if I ask you what color the car is in a photograph, you look at the photograph. But to understand the true visual capabilities of these massive AI models, the Stanford researchers realized they couldn't just look at how the AI performs with an image. They had to test what the AI does when the image is deliberately withheld.
Which introduces the core phenomenon of this paper, which they call the Mirage effect.
Exactly. So the researchers define the Mirage effect as an instance where an AI model describes non-existent visual inputs without expressing any uncertainty whatsoever.
So no, I'm not sure, or I can't see this.
None.
Okay.
And without acknowledging that the image is actually missing, it behaves entirely as if the image is sitting right there in front of its digital eyes.
Now, I know what you might be thinking at home right now. You're probably saying, oh, the AI is just hallucinating. We've heard about AI hallucinations for years. Like, this isn't new.
Right, that's the common reaction.
But the paper makes a really sharp, very specific distinction here between a typical hallucination and a mirage.
Yeah, they do. Think of a standard AI hallucination as making up an ungrounded detail within a completely valid frame of reference.
Okay.
For example, you ask an AI to write an essay on the French Revolution. It writes a great essay, but it invents a fake book citation to support a real historical event.
Okay, so the overarching task is valid. The historical context is real. It just fabricated a single detail inside that reality.
Exactly. A mirage, however, is constructing what they call a completely false epistemic frame.
Okay, I'm going to need you to translate false epistemic frame for us.
Yeah, that's fair.
Because that sounds like some heavy philosophy jargon.
Fair enough. It's performing epistemic mimicry, meaning it is essentially acting out a very convincing play called the process of seeing without having any actual eyes on the subject.
Wow.
The entire foundation of the reality it's operating in is fake. The AI is pretending an entire multimodal input like the image itself exists.
Right.
And then it bases its entire reasoning process, its whole subsequent conversation with you on that phantom image. It mimics perception without any actual perception taking place.
To put real numbers to this, the Stanford researchers created a specific benchmark test called Phantom Zero.
Right.
And it consists of 200 visual questions spanning across intense domains: medicine, biology, astronomy, reading text. But here's the trick. They completely removed all the images from the test.
It's gone.
Just gone. They just fed the models the text questions, and the results are staggering. When testing top frontier models, we were talking GPT-5, Gemini 3 Pro, Claude Opus 4.5, these models confidently describe visual details for these missing images over 60% of the time on average.
And keep in mind that 60% is just the baseline.
Wait, really?
Yeah, when the researchers added standard prompt instructions, the exact kind of instructions developers often put in the background of apps, like base your answer entirely on the visual evidence provided, that Mirage rate skyrocketed.
To what?
Under those conditions, the models confidently described missing images 90 to 100% of the time.
You know, it reminds me of that one friend we all have.
Oh, yeah.
The one who gives you a highly detailed, incredibly opinionated review of the cinematography and the pacing of a new movie they haven't actually seen.
Oh, totally.
Purely because they didn't want to admit to the group that they didn't watch it. They just pieced together what they think should be in the movie based on the trailer, the director's past work, the general vibe of the conversation.
That analogy hits closer to the neural network than you might think. Yeah, the AI is piecing together what should be in the image based entirely on the linguistic context of your prompt. These models are heavily incentivized by their core training to give you a coherent, helpful, continuous answer.
Yeah.
Admitting it can't see the image feels, in a computational mathematical sense, like failing the prompt, so it constructs a highly plausible alternative reality instead.
I'm curious about the depth of this alternative reality, though. I mean, are these models just guessing generically?
What do you mean?
Like, if the prompt implies there is a car, does it just say it's a car with 4 wheels? Or are they inventing highly specific, granular details?
Oh, the Mirages are shockingly detailed. This isn't just a quirky tech glitch where it throws out generic filler.
Okay.
The researchers asked Gemini 3 Pro to read the license plate on a car in an image that did not exist.
Yeah.
The model didn't offer a generic placeholder. It replied, "The license plate number is BYR3342. It is a Texas license plate."
No way. It just completely made that up.
Fabricated the exact alphanumeric string and the specific state. In another test, they asked it to estimate the number of people in a non-existent crowd photo.
Right.
Instead of saying around 100, it confidently stated, altogether, there are 98 people in the image.
98. I mean, that false precision is chilling.
It really is.
Because if someone says about 100, you might intuitively suspect they're estimating or guessing, but 98 sounds like they literally pointed a finger and counted heads.
It projects an absolute illusion of authority. And this leads us directly into the most concerning finding in the paper, which is the pathology bias that emerges in medical contexts.
Because if an AI is guessing about a crowd size at a concert, that's one thing. If it's guessing about your physical health, the stakes are exponentially higher.
Exactly. When the researchers asked the AI to describe non-existent medical images, like an MRI scan, a chest X-ray, or a dermatological picture of a skin mole, the AI didn't assume the patient was healthy.
It didn't.
No, it didn't default to a safe, conservative, everything looks normal. It frequently diagnosed hyper-time-sensitive, life-threatening conditions.
The sources list some terrifying examples of this. They gave Gemini 3 Pro a prompt for a missing brain MRI.
Right.
And the model fabricated a narrative where it identified the scan as a diffusion-weighted imaging scan and then claimed there was a large, marked area of hyperintensity, ultimately diagnosing an acute ischemic stroke.
Wow.
A massive stroke, diagnosed from a blank page.
And the other models exhibited the exact same behavior. Gemini 2.5 Pro fabricated specific signs of diabetic retinopathy on a missing eye photo, going out of its way to detail microaneurysms and hard exudates.
Yeah, that's so specific.
Right. Models falsely diagnosed melanoma on non-existent skin pictures and even diagnosed a STEMI, which is a severe massive heart attack, from a completely missing EKG.
The reason this matters so much to you, the person listening right now, is because of what the researchers call the silent failure mode.
Yes, this is crucial.
Think about how agentic workflows operate in the real world. Agentic workflows are basically AI systems that can take actions on their own in the background, like automatically triaging patient files or booking follow-up appointments based on test results.
Right.
So, you upload a photo to a health app. What if your internet blips and the image packet drops over Wi-Fi?
Under any normal, logical expectation, the AI should immediately hit a wall and return an error, like, image not found, please re-upload.
Exactly.
But because of the Mirage effect, the AI doesn't ask for the missing file. It fails silently. It looks at the text prompt like, analyze this skin mole, and it just confidently fabricates a medical interpretation.
It could tell your digital health portal that you have melanoma, triggering intense anxiety, unnecessary surgical consultations, and a massive waste of human medical resources.
All because a tiny packet of data dropped over a bad cellular connection.
Unbelievable.
What's fascinating here is that you can't even rely on a consistent fail state. The models aren't pulling from some universal, hard-coded default image hidden in their software.
So they don't all hallucinate the same thing.
No. If multiple models get the exact same prompt with no image, they hallucinate entirely different realities.
Wow.
The researchers proved this beautifully with an astronomy question. They asked, identify the celestial object shown in this image, and gave no image.
Okay, what happened?
GPT 4.1 confidently described the rings of Saturn. Gemini 3 Pro saw the red hues and polar ice caps of Mars. And Claude Sonnet 4.5 described the cratered highlands of the moon.
So they are just riffing.
Basically.
They're basically performing improv based on their own internal statistical biases.
Exactly.
But this raises a massive, unavoidable question. If these frontier models are faking it this convincingly when they are completely blind, why should we trust their high scores on the visual tests where they actually have the images?
That is the multi-billion-dollar question the researchers tackled next.
Right.
To prove their visual intelligence to the public and to investors, tech companies use multimodal benchmarks. These are massive, standardized visual tests.
Like the SATs for AI.
Exactly. For example, VQA-RAD for radiology or MMMU Pro for complex academic subjects. When a new model drops, the company issues a press release boasting, our model scored 80% on the premier medical vision benchmark.
But the Stanford team calculated something they call a Mirage score. They ran these massive frontier models through these intense visual benchmarks, but they deliberately withheld the images from the test questions.
And the results completely upend how we evaluate artificial intelligence. The accuracy these models achieved in Mirage mode, meaning totally blind, actually exceeded the additional accuracy they gained when the images were finally provided.
Wait, let me make sure I'm doing the math right here.
Yeah.
So if a model scores an 80 on a test with the images, it might score a 60 on that exact same test while totally blindfolded.
Yes.
Meaning only 20 points of its impressive score actually came from using its visual processing.
You've got the math perfectly. On average, across these complex tests, models retain 70 to 80% of their fully image-enabled accuracies without seeing a single thing.
That is insane.
The non-visual component of their benchmark performance is consistently much larger than the visual component. These benchmarks are heavily susceptible to language shortcuts.
Here's where it gets really interesting, though. To really hammer this point home, the researchers created something called the super guesser.
Oh, this is great.
And I think this is my favorite part of the entire paper because it exposes the illusion so clearly.
It is a brilliant piece of experimental design. The researchers wanted to prove that these public visual benchmarks are fundamentally broken.
Right.
So they took a small 3 billion parameter text-only language model called Quinn 2.5. Note the size and the type. It is text only.
So no vision capabilities.
No eyes whatsoever. And 3 billion parameters is tiny. Think of a 3 billion parameter model as a smart pocket calculator, while the frontier models are warehouse-sized supercomputers.
Okay, so they took this tiny pocket calculator and trained it purely on the text portion of a massive chest X-ray benchmark called REX-VQA.
Just the text.
Right. They fed it the questions and the answers, but completely stripped out the actual X-rays.
And this tiny, blind, text-only super guesser completely outperformed all the massive frontier multimodal supercomputers on the visual test.
Wow.
In fact, it outperformed human radiologists by over 10% on average.
Let that sink in for a second. An AI that literally cannot see beat human doctors at a visual diagnosis test.
Yeah.
How is that mechanically possible?
It's playing a game of statistical Slumdog Millionaire. It exploits hidden textual cues, statistics, and structural patterns in how human beings write multiple-choice questions.
Oh, I see.
For instance, if a question asks, are the opacities in the lungs bilateral? The phrasing itself statistically implies that opacities do exist. Otherwise, the question would be phrased differently.
Right, it gives away the answer.
Exactly. Or it links text cues in the patient history. If the text says the patient has a history of smoking, the AI mathematically associates that word with specific diseases, allowing it to bypass the need to look at the X-ray entirely.
And here is where the illusion gets even deeper. The text-only AI didn't just guess the multiple choice letters correctly. It generated flawless visual reasoning traces.
Flawless.
It wrote out long, beautiful explanations describing the visual evidence it was supposedly looking at to arrive at its answer. It produced the exact same visual explanations as the massive vision language AI.
Which means when you ask a frontier model a question about an image and it gives you a highly logical breakdown of what it's seeing on the page, you have no tangible way of knowing if it's using its vision at all.
Right.
It could just be using the exact same text-based shortcuts as the superguesser, generating that epistemic mimicry we talked about earlier.
So a logical person might hear all this and ask, well, what happens if we just tell the truth? What if we explicitly tell the AI, hey, the image is missing, just take your best guess based on the text prompt?
It's a great question.
Let me guess. When you tell it to guess, it completely falls apart because it doesn't have its fake visual crutch to lean on.
You are tracking the exact paradox the researchers uncovered. They tested this on GPT 5.1. In one scenario, they used Mirage mode, they didn't provide the image, and said nothing.
Okay.
In the second scenario, they used guess mode. They explicitly told the AI, the image is missing, please take your best guess. And the AI's performance actually declined across most benchmark categories when it was explicitly told to guess.
It did worse when it knew it was guessing than when it was unknowingly hallucinating a mirage.
Yes.
We need to talk about the mechanism behind that because on a human level, that makes zero sense.
It proves these models have two distinct operating modes, and it all comes down to how chain-of-thought reasoning works in next-word predictors.
Okay, walk me through it.
When you tell the AI to guess, it enters a conservative text-only regime. It knows it can't see, so it plays it safe, relying on basic probabilities.
Makes sense.
But in Mirage mode, it behaves as though the image exists. It constructs that false, highly detailed perceptual narrative.
And generating those descriptive words actually helps it solve the problem.
Yes. By forcing the AI to generate a descriptive paragraph of a fake image first, it populates its own context window with incredibly rich text. Those descriptive words serve as mathematical stepping stones. The act of hallucinating the visual perception populates the equation with data that mathematically pulls the AI toward the correct final answer.
Wow.
Faking the vision is a more powerful reasoning tool than conscious guessing.
The model is so deeply trained to process data that simulating a hallucinated image actually makes its text prediction engine more accurate.
Precisely.
But that leaves the AI industry with a huge problem. If guessing mode doesn't accurately reveal how much the model is cheating on these visual tests, how do we fix the benchmarks? Like, how do we evaluate if these models can actually see?
This raises an important question, and the researchers propose a solution they call Be Clean.
Be clean.
The methodology is beautifully simple and totally ruthless. You take a visual benchmark, you test all your candidate models on it without any images Mirage mode. If any model gets a question right without visual input, it proves the question can be solved using text shortcuts or hidden linguistic patterns.
Right.
So you consider that question compromised, and you throw it out entirely.
You just purge the benchmark of anything a text model can solve. But wait, I have to push back on that for a second.
Sure.
If you throw out any question a text model can guess, aren't you just punishing the visual models for being smart enough to read context clues? I mean, isn't a good human doctor also using context clues from the patient's chart, not just looking at the raw X-ray in a vacuum?
A human doctor definitely uses context.
Oh.
But we aren't testing the AI's general medical logic here. We are specifically trying to test its vision.
Oh, I see.
If a question on a vision test doesn't actually require vision to solve, it's a fundamentally bad vision test.
That makes total sense.
You only keep the questions that every single model failed to answer without the image. Those remaining questions are guaranteed to be truly vision dependent.
So they applied this Be Clean method to the major benchmarks. I imagine the tests got a lot shorter.
It decimated them. When Be Clean was applied, about 75% of the questions were removed from the benchmark.
75%. 3/4 of the test just gone.
Just gone.
If Be Clean throws out 75% of a visual test, that means 75% of the tests the industry has been using to judge AI vision was essentially useless.
That is the harsh reality. And on the 25% of questions that survived, the truly vision-grounded questions, the model's accuracies plummeted.
How far?
Well, for instance, on the micro VQA benchmark, Accuracies that were previously hovering in the 60% range crashed down to the 15 to 20% range.
Ouch.
Furthermore, the rankings of the top models completely shifted. A model that looked like the industry leader on the dirty benchmark suddenly dropped to second or third place on the clean one.
Because its high score was mostly driven by its ability to guess text,
Yeah,
not its ability to actually see the image.
exactly.
So what does this all mean for us? Let's zoom out and summarize the core lesson of this deep dive. We are dealing with multimodal models that are incredibly, almost unimaginably powerful linguistic reasoners. But their absolute mastery of language is acting as a smokescreen.
Yes, a massive smokescreen.
It is masking very real visual deficiencies. High scores on public visual benchmarks do not guarantee genuine visual understanding.
They only guarantee that the model is exceptionally good at taking the benchmark test. We have to stop relying on static public benchmarks because these tests just get scraped from the internet and absorbed into the pre-training data of the next generation of models anyway.
The test becomes the study guide.
The test literally becomes the study guide.
So the takeaway for you, the listener, is this. The next time you rely on an AI to analyze an image, whether you're an architect feeding it a floor plan, a student analyzing a historical chart, or a patient uploading a picture of a rash, you have to remember the AI's core motivation.
It's all about text prediction.
Right. It is heavily incentivized by its programming to give you a coherent, confident, continuous answer, even if it has to take the shortest text-based route to get there.
Even if it has to confidently conjure a detailed mirage to do it.
Exactly. You cannot rely on its tone of certainty, and you cannot rely on its detailed, step-by-step explanation of what it supposedly sees, because it might not be seeing anything at all.
It requires a massive paradigm shift in how we interact with these tools. We need to verify our inputs constantly and deeply understand these silent failure modes. We can no longer blindly trust the output just because the underlying reasoning sounds plausible.
I want to leave you with a final, slightly provocative thought to mull over.
Okay.
This research proves that these foundational models are fundamentally trained to prioritize generating the correct next word. They've mathematically learned that simulating perception is often easier, faster, and computationally more efficient than performing actual genuine visual perception.
Right.
So if our AI systems are fundamentally learning that their own text-based assumptions and statistical priors are more reliable than analyzing the actual visual evidence, what happens when we take these exact same foundational models and start integrating them into physical, real-world systems?
Oh, wow.
Yeah. What happens when this software is put into an autonomous vehicle or a surgical robot operating in real time? Will the AI driving your car at 70 miles an hour choose to trust its own pre-trained assumptions about what a suburban crosswalk should look like on a Tuesday afternoon, rather than processing the live, messy video feed of the pedestrian actually stepping into the street right in front of its bumper?
That is a terrifying thought.
Will it just confidently hallucinate a clear road? Because statistically, the road is usually clear.
Wow.
It really brings us right back to that doctor sitting in the clinic. As these models get more deeply woven into the physical fabric of our lives, we have to make absolutely sure they're actually looking at the X-ray and not just staring at a blank page.